this course is for numerical analysis, and these are the contents that we are going to discuss in this course, that the floating point representation, right? Nonlinear equation, there we will do different type of methods, bisection method, fixed point iteration methods, their convergence, Newton method, and other methods also. Then we go for the linear system and finding the eigenvalues. Then we will go for interpolation and how we can approximate the data, and then we go for the numerical integration, differential equation. So basically this course is about that if we have the numerical analysis, at its name indicates we are doing some approximation here. This course we are doing when we do not suppose we have any function, right, f of x, any function, and whose analytic solution is not possible, and it whose analytic solution is difficult to find. So in that case, we can approach for the approximation. So this course is about is difficult to find. So this course will tell you how we can find the approximate solution for some function, how we can find the approximate integration when its analytic solution is not possible. So instead of finding the analytic solution in this case, what we do, we can go for the approximate way. So whenever, like if we have equation f of x is equal to, if we have quadratic equation x square minus 2 equal to 0, then we can simply say that its roots are plus minus root 2. Then if the equation becomes complex, like I am writing x sine x minus 2 raised to the power cos x plus 7 is equal to 0, and I'll say, but which value of x should satisfy this equation? So instead of finding the analytic solution, we go towards the approximate solution. So for that, we need some representation of the number, that the computer has some representation, so that we are going to do the floating point representation. Floating point representation of a number. That is the first topic in the syllabus. So what is the definition of this? So the definition of this is that for any real number x, for any real number x, we can associate a floating point representation. We can associate a floating point representation that is denoted by that will be denoted by FLX, because we are giving the floating point representation to x, and is represented by FLX, that is the plus minus, that the sign can be positive, 0.A1, A2, AN, this is beta into 10 raised to the power beta E. So here, firstly we will discuss the definition, then we go for the example. So here, what are these actually? This is denoting the sign, the number can be positive or negative. So if the number is positive, we don't insert the sign. If the number is negative, insert the sign. So these AIs are all integers. AIs are positive integers. Or we can say non-negative integers, because we can consider this as 0 also. So AIs are non-negative integers, and this is called here, because these are the integers, and it will take, obviously this will be from 0 to 9, and this here, this beta is called the base of the number. Here E is called the exponent, and this part A1, A2, this part we call, say this is your mantissa part, or we can say the fractional part. Mantissa, or we can say the fractional part. One thing, in this course we will take the beta as 10, that is we will take the decimal point representation. So when we talk about beta, when we represent the number in form beta, this is called beta based floating point representation. And if I am taking the beta is equal to 10, this will be known as decimal floating point representation, right? For example, we have any number, we can represent it into the form of floating point number. So like for example, I have the number is x is equal to 43.128, right? So this number is positive. So we are not considering the sign here as positive. So when we write the floating point representation, it says it should start from the zero, right? So it will be 0 point. I can shift these numbers to my right, that is 43128, and that can be written as 10 raised to the power 2, because here we are dealing with the decimal number. So we have considered base as 10. So this is my base, and here this is my exponent, and this is the floating point representation of the given number x. So here this is my mantissa that I have already beta. This is your beta, that is the base, right? That is your 10, and 2 is the exponent, right? If you have any number, like if you have any number x is equal to we can write this x is equal to, I have minus 0.43128, right? We can write it in the floating point representation. This will be 0.43128 into 10 raised to the power 0, because we have not shifted term anywhere. So negative sign is denoting that it is a negative number, and this is your mantissa part. And here the same, this is the base, and in this case I have exponent, that is your 0, right? So when we write a number, you can write some remarks over here. So the first remark is that the number 0 is written as 0.000 up to so on. We can take up to some places into 10 raised to the power exponent as the floating point representation, right? So if we have number 0, we can represent number this in this way. Second is this representation, that means I am talking about the floating point representation. This representation, that means floating point representation, is not unique. ये कैसे यूनिक नहीं है? Because if I have the same number like this, I am writing x is equal to 431.128. I have given the floating point representation. This is the floating point representation of this number that I have written as 0.43128 into 10 raised to the power 2. So this is the form. I can also write the same number in the way 0.043128 into 10 raised to the power 3. So this number is same as 43.128, and this is one representation. Here your base is 10 in both the cases, but here you can see in the first case you have exponent is 2, and in the second cases you have exponent is 3. That means the floating point representation is not unique. So to represent it in the unique way, what we can do the normal form, or we can say the standard form. Normal form or standard form. So what is your normal form or standard form? Any non-zero floating point, any non-zero floating point number is in normal form, if the value of the mantissa, if the value of Mantissa, if the value of Mantissa lies in the interval -1 to -1 by beta or 1 by beta to 1. That means if we are considering the base as 10, that means for the decimal point representation, my mantissa should lie between -1 to 0.1, -0.1, or it should lie between from 0.1 to 1. That means in short, हम क्या कह सकते हैं कि जो ये नंबर है मेरा A1, ये मेरा 0 नहीं हो सकता, because for the floating point representation, this number cannot be 0 if it is in the normal form. For example, if we talk about the same number FLX, right? If I'm writing this number 0.43128 into 10 raised to the power 2, so this number is in my normal floating point representation. This is the normal form of the representation. But on the other hand, I am writing this 0.043128 into 10 raised to the power 2. This is not normal floating point representation of the number. So if you have any number like this, you have any number x is equal to, you can write any number 0.0025, and you have to write, no doubt this is in the floating point representation, because I can take here into 10 raised to the power 0, right? That is 10 raised to the power 0 will be 1. So if I'm writing in the floating point representation, that is the normal form, this will be the same. If I'll write in the floating point representation, this is okay, because there is no condition on the mantissa part. But if we are writing it in the normal form, here can't be zeros. That means the A1 term in the mantissa part, that should be non-zero term, right? So we can write it in the normal form. This is will be 0.00. This will be shifted, right? And we can't write it in the normal form. Zeros will be shifted and A1 will come out to be this, because we have shifted the terms towards the left. So we have shifted 2 zeros. So here it will be 0 minus 2, that will be -2. For example, if you have any number 0.00000123, write into 10 raised to the power 1. And then if you want to write it into the floating point representation, that should be the normal. So we will make this A1 should be non-zero. So it will be 0.123 into, here the base was already 1, base is 10 and the exponent 1. We have shifted 3 zeros. So that will be -3. So this number is 0.123 into 10 raised to the power -2. So this is my floating point representation in the normal form, right? So the next part is the overflow and underflow. Overflow and underflow, because we are storing the number, क्योंकि हम नंबर जो है अपने कंप्यूटर में स्टोर कर रहे हैं, that should have limited space. तो इसका मतलब अगर आपका नंबर बहुत ज्यादा लार्ज है, then there will be overflow. और अगर आपका नंबर बहुत छोटा है, that can't be stored in the computer, that will be your underflow. So we can write like this: if a number is too large, if the number is too large to fit into the floating point representation, to fit into the floating point representation, that is because we are talking about the exponent, कि अगर आपका एक्सपोनेंट जो है वो बहुत ज्यादा बड़ी वैल्यू से m, that is the maximum value it can store, the computer can store. And if your e exponent value, this value becomes greater than n, जितनी वो आपकी वैल्यूज स्टोर कर सकता है, जैसे हम बोलते हैं 16 bit that it can store 16 digits, right? So if it will be occur, then this is the situation, then an overflow is obtained, and if a number is too small, and if a number is too small, too small to fit, that is, if my exponent is less than very small, that is less than minus m, then underflow is obtained. Then underflow is obtained. When we will do the calculation, so in the calculations, if your overflow occurs, if overflow occurs, we say this is fatal, and if underflow occurs, we say this is non-fatal. So underflow occurs, then we say this is non-fatal. So this is all about today, that we have done the floating point representation. If you have any number, you can represent it in the floating point representation, but that representation is not unique. अगर आपको unique चाहिए, that means you have to convert that number into the normal floating point representation, and that representation will be your unique. So in the next class, we will start with the rounding and chopping, because the computer has limited space to store a number. Okay, thank you for today.